Hi everyone, welcome to the video lecture 2. The contents that will be discussed in this video lecture will be about the fatigue fracture, fatigue load, fatigue fracture surface, and fatigue life regime and fatigue design. So we are going to see the definition of various terms used in the fatigue fracture, what are the classifications of fracture types, and what is a fracture type and the material strength for that, and various fatigue fractures, and we'll see the examples of the fatigue failure accidents. If you see the definition for the concepts behind fatigue and fracture mechanics, it starts with the fracture. The fracture is the local separation of an object or material into two or more pieces. And if you see the definition of a fracture in fracture mechanics study, it is defined as a process of forming a new surface through irreversible process under mechanical load. So, if you are applying a load over a given component, that can be called as a mechanical load. And when the mechanical load is applied over the given component, there is going to be a formation of a new surface, and this new surface created cannot be reversed back. That is what we call it as a irreversible process. So if the surface created cannot be able to get back to its old surface, then that is what we call it as the fracture. If you see the definition for the term failure, it means that a machine fails to perform. It can be a machine, or it can be a system, or it can be a mechanism. If these entities fail to perform the intended task, it is called as the failure. So the term of failure is widely used in reliability engineering. It may happen even without the destruction. We can see the various kinds of failures in the given examples here. The classification of fracture types, it can be called as the brittle fracture or the ductile fracture. So the picture shown in this slide, it gives a perfect example of the fracture uh, of the type brittleness. So the brittle fracture uh, experiences, there is no any apparent plastic deformation, and this plastic deformation takes place before fracture, but once fractured the crack propagates rapidly. So there is going to be a set of two phases that occur during the failure of the material as far as the fracture is concerned. One is the crack initiation, and the next one is the crack propagation. So for the brittle fracture, the crack initiation, it has some kind of resistance, but once the fracture is done, the crack propagates in a very rapid way. Once fractured, the destruction continues to proceed after force removal. If we see the second concept of a fracture or the failure due to the fracture mechanics, it is called as the ductile fracture. In the ductile fracture, there is going to be the extensive plastic deformation which occurs before the fracture. So, there is going to be a substantial amount of plastic deformation period in which the material gives some sort of resistance to its level against the applied load, and after giving a tremendous amount of resistance, the material fails, and the failing stage is called as the fracture. So in the ductile fracture, it is relatively slow, and the crack propagation is very stable, but the crack propagation is unstable in the brittle fracture. That makes the difference between the brittle fracture and the ductile fracture. So the crack propagation is stable in that cracks are in equilibrium at each point. So the crack propagation stops when the load is removed, and an extra load must be applied for further crack propagation. If we see the definition for the word fatigue fracture, it is defined as a destruction as a result of repeated loading and unloading. When a component is subjected to a load which is of the cyclic type or the repetitive type, that is, we are applying the loading and unloading in a repetitive manner, the destruction will be followed over the given component, even if the component is subjected to a very small amount of force. So, as per the American Society for Testing and Material, the definition is given as it is a process of progressively localized permanent structural change occurring in a material subjected to conditions that produce fluctuating stresses and strains at some point or many points, and which may culmination cracks or complete fracture at a sufficient number of fluctuations. So, if you want to take the generalized definition of a fatigue fracture, it can be termed as a material received external or internal repeated loading, that is, cyclic loading, changes in local organization due to the repeated load, eventually leads to cracks or the fracture process. So, the given pictures are the few examples of the fatigue fracture. There is going to be another fracture which can be experienced in the materials, which is termed as the creep fracture. So, when the fracture occurs over the given component under the influence of the temperature, it comes under the creep fracture. So, the time dependent deformation, even with the constant load at over a certain period, is termed as the creep fracture. The creep deformation accelerates at some point, resulting in a rupture. If you take the graph between strain versus time, the creep fracture curve, it follows a very linear way during the stage one, which is called as the primary creep, and it moves towards the strain at a constant rate, which becomes the stage two, which is termed as the secondary creep. And when it enters the stage three, within a short amount of time, the strain is developed in a tremendous way and it leads to the rupture. So, this can be plotted in a strain time graph in this manner with three stages, which are named as primary creep, secondary creep, and the tertiary creep. So, if the deformation is occurring as per the given graph, then it can be termed as a creep fracture. Then there can be delayed fracture and environmental assisted fracture. Uh, which comes under a different study of fracture or the failure mechanics. And in this case, the environment plays a major role here for the deformation or the fracture occurring over the given system. If we see the fracture type and the material strength, we need to study a few important topics uh, such as strength of materials, fatigue strength, etc. The strength of materials is considered in two cases: with and without flaws of the cracks, and basic strength is normally without the flaws. The fatigue is very important in terms of strength of the materials, and fatigue strength is one of the most important parameter in the mechanical design. Cyclic loading is also called repetitive loading and unloading. All the machines and structures get cyclic loading in nature, so most of the fractures result from fatigue. Lower yield stress or the proportional limit. Although the cyclic stress range is smaller than the static fracture stress or yield stress, the fatigue fracture occurs here. And this is going to be the important phenomena when we consider the fatigue failure for any kind of material. There is going to be another terminology which is termed as the fatigue limit, which is also called as the endurance limit. The fatigue limit or the endurance limit are the expressions used to describe a property of the material, the amplitude of cyclic stress that can be applied to the material without causing the fatigue failure.